lecture is on circuit diagrams. Drawing realistic pictures of circuits can be very difficult. For this reason, we have common symbols to represent each piece. Here we see a resistor, a battery, and wire. Note that circuit diagrams do not show where each part is physically located. Draw a simple circuit that has a 9-volt battery and a 3-ohm resistor across its terminals. What is the magnitude and direction of the current? Go ahead and pause the video now and solve this one. Okay, so let's take a look and see if you have the right answer. You should have had a battery, a 9-volt battery, a 3-ohm resistor. Using Ohm's law, we have V divided by R is the current, which is 3 amps. The amps flow from positive to negative terminal. There are 2 ways to add a second resistor to the circuit. We can add them in series, where all the charges must move through both resistors to get to the negative terminal, or we have charges that pass through either R1 or R2, but not both, and we call this a parallel circuit. So this one here is series, this one here is parallel. Are the following sets of resistors in series or parallel? Go ahead and pause the video now. Okay, so let's take a look. For this one over here, this is actually in parallel, because notice that this point is in contact with the battery, and this point here is in contact with this battery. That makes these 2 resistors wired in parallel. These 2 here, we only have one current path, and therefore they are wired in series. Resistors and voltage from batteries determine the current. Circuits can be redrawn as if there were only a single resistor and battery. By reducing the circuit this way, the circuit becomes easier to study. The process of reducing the resistors in a circuit is called finding the equivalent resistance. What happens to the current in the circuit to the right? Go ahead and pause the video now. Okay, so let's see. The current passing through all parts of the series circuit is the same. So in this example, I is equal to I1, which is equal to I2. What happens to the voltage as it moves around the current of the circuit? Go ahead and pause the video now. Okay, so let's see if you have the right answer. The sum of the voltage drops across each of the resistors in the series circuit equals the voltage of the battery. So in this case, the voltage drop on R1 plus the voltage drop on R2 is equal to the total voltage of the battery. If we have a series circuit, the equivalent resistance is equal to R, which is R1 plus R2 plus R3. To find the equivalent resistance of a series circuit, you just add the resistances of all the resistors. If you add more resistors to a series circuit, what happens to the total resistance? It would increase. What is the equivalent resistance in this circuit? That's right, it's 8 ohms. What is the total current at any spot in this circuit? Be careful. Okay, in this case, we have to use the total resistance and divide that into the total voltage. So 9 volts divided by 8 ohms gives us 1.125 amps. If we were using significant digits, it would be 1 ampere. What is the voltage drop across R1? Okay, so let's take a look. The voltage drop on R1, well, we need to find the current first. So the first thing we need to do is solve for the total resistance. In this case, it's 8 ohms. Okay. Next, we need to find the net current. We take the total voltage of 9 volts divided by the 8 ohms, and that gives us a current of 1 ampere. The voltage drop on R1 is going to be IR1, so we multiply I times R1, and that gives us 5.6 volts. What is the voltage drop across R2? Go ahead and pause the video now. Okay, so let's see if you have the correct answer. Okay, first you find the net resistance, which is 8 ohms, then you find the current, which is 1 amp. The voltage drop on R2 is going to be 1 ampere times 3 ohms, which gives us 3 volts. A good way to check your work is to see if the voltage drop across all the resistors equals the total voltage in the circuit. And we covered that in class. How much power is used by R1? Go ahead and pause the video. Okay, so let's take a look at your answer. By using the numbers we already have, we know that the voltage drop on R1 is 5.6 volts. By multiplying that by 1.1 amperes, we end up getting 6.3 watts. So now let's talk about parallel circuits. What happens to the current in the circuit to the right? That's right, it's going to split. It has to make a decision. Is it going to go up through R1 or is it going to go down through R2? The sum of the currents through each of the resistors in this parallel circuit equals the current in the battery. So I, the total current in the battery, is equal to I1 plus I2. What happens to the voltage as it moves around the circuit? That's right. It's going to remain the same. The voltage across all the resistors in a parallel circuit is the same. V is equal to V1, which is equal to V2. Okay, if you look at this derivation, we find that we end up with the 1 over the equivalent resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3. If you add more resistors in parallel, what happens to the total resistance of the circuit? Well, it depends on the value of the smallest resistor. The smallest resistor will make that the limiting factor. So the equivalent resistance is always less than the smallest resistor added in parallel. What is the equivalent resistance in this circuit? Go ahead and pause the video. Okay, so let's take a look at your answer. Using the 1 over R equivalent is equal to 1 over R1 plus 1 over R2, we end up getting 2 ohms. Don't forget here to take the inverse of your sum of your inverses. What is the voltage at any spot in this circuit? Hopefully we're able to answer that immediately. It is 18 volts because it is a parallel circuit. What is the current through R1? Go ahead and pause the video. Okay, so remember, the current is going to be V1 divided by R1, which is 18 divided by 3. That gives us 6 amps. What is the current through R2? Go ahead and pause the video. Okay, so let's take a look at your answer. We now take 18 divided by 6, and that gives us 3 amps. What is the power used by R1? Go ahead and pause the video. Okay, so let's take a look at the answer. We know that the current is 6 amps. Power is equal to IV, so we take 6 amps times 18 volts, and that gives us 108 watts. What is the power used by R2? Go ahead and pause the video. Okay, so let's take a look. The current through I2 is 3 amps. We take 3 amps times the 18 volts, and that gives us 54 watts. What is the total current in this circuit? This is the one that you're going to need to redraw. And remember to draw your current paths before you solve this one. Go ahead and pause the video now. Okay, so let's take a look at the solution. The first thing we're going to do is we're going to add R1 and R2 in parallel, and that's going to give us 2 ohms. Okay, now that we have a 2 ohm resistor here, it's in series with the 4 ohm resistor here. So 2 plus 4 gives us 6 ohms. The current is equal to the total voltage of the battery, 18 volts, divided by the total equivalent resistance, which is 6 ohms. That gives us 3 amps. What is the voltage drop across the third resistor, R3? Go ahead and pause the video now. Okay, so let's take a look. V equals IR. V is equal to 3 amps times 4 ohms, which gives us 12 volts. You may be thinking, wait a minute, can I use the 3 amps from the previous part? The answer is yes, because for this resistor, the total current runs through it. What is the current through the first resistor? Go ahead and pause the video. Okay, so let's take a look. We have to find out what the voltage drop is for V1. V1 is going to be the total voltage minus V3, which is the voltage drop on this resistor. Okay, this is a little bit of a tricky way of doing it. It's not really the way I recommend you do it. I recommend you use the reduced circuit, and we know that this here gives us a 2 ohm resistor, and we know that the total current is from the previous part. Let's see, the total current is 3 amps. So we take the total, back here. We take the 2 ohms times the 3 amps, and that gives us the voltage on this resistor. Okay, so I don't really recommend that you do this method, but it is another way of looking at it. We know that if you look at the circuit, this voltage drop plus the voltage drop on either of these must be equal to the power supply, okay, which is 18. So we take 18 minus this voltage drop on R3, and that has to give us the voltage drop on R1 and the voltage drop on R2. Once you have that voltage drop of 6 volts, you then take the 6 volts divided by the 3 amps, and that gives you 3 ohms, and that gives you 2 amps. If you need me to go over this tomorrow, just please make sure you let me know at the beginning of class. Okay, in the next video, we're going to talk about measurements.